Hello, Ronan and Leon. It's your Zayde, Mason. Hi. And
Kermit the Frog.
so today, Kermit and I are going to talk to you about organic chemistry.
Organic chemistry.
So today we're going to talk about organic chemistry, and we're going to talk about how mostly carbon, which is organic, the thing that we call organic, works with other things. But let's begin at the very beginning. A very good place to start. This is a ball.
It's green, like me.
Well, in this case, it is a ball, and this ball can stick to two other balls. Notice the green ball.
The green ball can stick to two other balls.
Okay, well, this one that's yellow,
Not green.
can stick to three balls. See, that's got three balls. And then this ball, this one, red one, can stick to four little balls, little blue balls.
That looks very interesting.
So, each different type of ball, the little blue one, and the red and green and yellow and red one, as I said, red, each different type of ball can stick to a number of different other balls. The little blue ones by themselves, the green one
can stick to two balls. The yellow can stick to three. And the red one can stick to four.
Now, these balls can, when you put them together, can make different shapes. Imagine all the different shapes you can get when you put them together.
That almost looks like a circle of red balls.
And just by combining them, you get all these different shapes.
Look at all the shapes. Wow.
All right. So, guess what? These balls are like atoms. They represent atoms in this case. And atoms make up everything.
Which is why we don't trust them.
That's a joke. So, each different type of atom, which is represented by the balls, red, green, yellow, and the little blue ones, each different type of atom can stick to a certain number of other atoms.
Yes, they can.
Okay. The important bit here, though, is that we're going to talk especially, as mentioned, about carbon represented by the red one. So this is the carbon atom, and it's very special, especially for this particular subject.
Yes, it is. We're going to talk about organic chemistry.
No, don't talk about it too much yet, but in particular, the red ball that represents carbon has four other little atoms attached to it.
Yes, it does.
By the way, we haven't mentioned it, but the little blue ones are actually supposed to be hydrogen, but we'll get to that another time. Anyway, when it does stick, it sticks really well. So what have we got, Kermit?
Well, we got
Well, what is this one?
methanediol is in the upper right-hand corner. Diethylamine is over there. And methanol at the very bottom.
So yes, you've got that, and look at this huge one.
Oh my goodness, look, that's huge!
The carbon likes to help make other shapes.
And look how big of a shape that is.
Yes. So when you put carbon together, these with other things, or even itself, these are called organic molecules.
Organic molecules, which is the subject of this particular discussion and this book.
Yes, it is. Okay, so the point is, there are many different organic molecules. So what have we got here? That looks like benzene.
That definitely looks like benzene.
It is. And up in the top left here, that is butane.
Butane? We know what you can use that for. Burning things, huh? You'll figure that out when you're much older.
But we're not going to talk about that right now. And at the bottom, ethanol.
Ethanol? Oh, that's a big discussion when you're much older.
But ethanol is something that you run into all over the place. Okay, something else it can make is medicine. Ooh, what's that?
That is acetylsalicylic acid.
Also known as aspirin. And some are very smelly. Vanillin, which is also called 4-hydroxy-3-methoxybenzaldehyde. So that's vanillin. And that is what makes cookies taste so good, and vanilla frosting.
Yay, vanilla frosting.
Other things, oh look, this is really important. Cotton, which is cellulose, is made out of carbon chains.
And you know how important that is, Leon, because if you don't wear cellulose, you get a rash.
That's right. Amylose, which is found in
Bread! I love bread. Bread is tasty. It makes sandwiches.
and also histidine in amino acids.
Those can make up things like cheese and other stuff. Histamine can also create allergies too, but we eat it.
And then sodium laurate.
That's used for soap, which you use to wash yourself.
Sometimes it can be used for fuel like heptane or isooctane.
Usually called octane, it's what you put into your car if you drive an electric vehicle.
So, plants contain all kinds of organic molecules.
Glucose, which is also a sugar,
And
chlorophyll. Look at that huge one. That's what makes things green, like me.
all right, so even you contain lots of organic molecules. Like you are carbon-based, just like they say in Star Trek. There's adenine.
Adenine? What's that?
I actually don't even know. I'm not a chemist. I'm a physicist. Acetone.
Acetone? Don't they use that for fingernail polish?
They do, but you contain it as well. And glutathione.
Glutathione? What's that?
Again, I'm not a chemist, but I know we contain it. The main point is all life on Earth contains organic molecules. And all life on Earth needs carbon. Even you. And me. And Kermit.
I contain carbon too.
So, now you know organic chemistry.
Yay!
So, that's it. I know this is a particularly long book, but Kermit and I really wanted you to learn about organic chemistry, and hopefully we'll have other discussions about all the different things we saw here, okay? I love you both very much. I hope you guys are having a wonderful day, and go and eat something with chlorophyll in it, like plants. Yay!
Yay!
All right, this is your Zayde Mason
And Kermit the Frog.
signing out.